Oh, I hate ending on a mistake. So the last video had this mistake here because cosine of pi is actually -1. So 1/2 minus -1 is +1. So 1/2 plus 1 is a positive number. And then 11 pi over 6 here, which is this point right here, 11 pi over 6 would have a positive cosine of square root of 3 over 2. So we have 1/2 minus square root of 3 over 2. And we know square root of 3 is about 1.7. It's definitely bigger than 1, so it's going to be a negative. So our derivative is going to be negative here, which means our function is going to be decreasing. Oops, I forgot to change this other one. So this function's increasing here. Oh, sorry about the mistake. So our function is decreasing from 0 to pi over 3. So pi over 3 is our critical number at pi over 3 is a max or a min, you tell me. If it decreases from 0 to pi over 3, and then from pi over 3 to 5 pi over 3 it increases, what's going on at pi over 3? So if the function's decreasing and then increasing, this must be a minimum at pi over 3. So we've identified the open intervals in which the function's increasing or decreasing. From 0 to pi over 3, the function's decreasing. Pi over 3 to 5 pi over 3, the function's increasing. And 5 pi over 3 to 2 pi, the function's decreasing. Then apply the first derivative test to identify all relative extrema. So since the derivative changes sign at pi over 3, since the derivative changes from negative to positive, or think about it this way, as the function, because the function changes from decreasing to increasing. The first derivative test says that that is a minimum. And then at 5 pi over 3, the derivative changes sign from positive to negative. So our graph changes from increasing to decreasing. So using the first derivative test, since the derivative changes from positive to negative, the function has a maximum at 5 pi over 3. And often they will ask you to find the y value for these values. So for our minimum, the y value, you plug in pi over 3 here and pi over 3 here. So we'll have 1/2 times pi over 3 minus sine of pi over 3. Sine of pi over 3 is 1/2. So we have 1/2 times pi over 3, which is pi over 6, minus 1/2, which is 3/6 if you want to do it that way. So pi minus 3 over 6. And then our maximum is 5 pi over 3. So if we plug 5 pi over 3 in there, 1/2 times 5 pi over 3 minus sine of 5 pi over 3. Sine of 5 pi over 3 is negative 1/2. Whoa, what did I do there? That's not 1/2 there. Making a lot of mistakes here. Sine of pi over 3 is square root of 3 over 2. Let me back up here. All right. So the 1/2 times pi over 3 is right, minus sine of pi over 3, and sine of pi over 3 is square root of 3 over 2. So we have pi over 6 minus square root of 3 over 2. Or if you want to get a common denominator, it's pi minus times 3, so 3 root 3. Messy. Too messy. Pi minus 3 root 3 over 6. And then sine pi over 3 here is negative square root of 3 over 2. So we have 5 pi over 6 minus negative square root of 3 over 2. So that's plus, getting a common denominator. So we have 5 plus 3 root 3. 5 pi plus 3 root 3. Over 6. So identified all relative extrema and then graph it. So here's our graph between 0 and 2 pi. If we zoom in here a little bit, we'll see that I'm exaggerating it here a little bit, but it looks like that. So you can see that our min at pi over 3, it's a relative min, and a relative max at 5 pi over 3. So there to there. It matches. All right, try this one. Find the critical numbers of f, if any. Find the open intervals in which the function's increasing or decreasing. Apply the first derivative test, and then identify all relative extrema and then graph it. So the derivative to find our critical numbers is 2/3 times x squared minus 4 to the negative 1/3, and then it's a chain rule, so times 2x. So that's 4x over 3 times the cubed root of x squared minus 4. So our critical numbers are where this either equals 0 or where it's undefined. It equals 0 at 0. That's where the numerator equals 0. 4 times 0 would give us a 0. And then in the denominator, what would make that equal 0? So if we want to set the whole denominator equal to 0, you can do that. Divide by 3 on both sides. We'll get cubed root of x squared minus 4 equals 0. Cube both sides. We get x squared minus 4 equals 0. Add 4 to both sides. We get x squared equals 4. And take the square root. We get positive and negative 2. That's where the derivative is undefined. So just looking at the graph to verify that, you can see that the derivative is undefined at negative 2 and 2 because it's got a sharp turn. It's still a continuous function, so the function itself is defined everywhere, but the derivative is not defined, so we can't find the derivative. It's not differentiable at negative 2 and 2. And you see at 0, we're going to have a horizontal tangent. So let's say we didn't have the graph, we're just analyzing it with or without the graph. These are our critical numbers. So then we want to use open intervals, and this is a graph that goes on forever, so negative infinity to negative 2, negative 2 to 2, sorry, negative 2 to 0, 0 to 2, and 2 to infinity. Again, you can use a number line if you prefer. Just make sure you mark off and talk about each place. So if you talk about this interval from negative infinity to negative 2, plug a number into the derivative like negative 3. The numerator is going to be negative, squaring a positive. Squaring a negative makes it positive. So this will be a positive, cubed root of it still be positive, times the 3 will be positive. So we've got a negative divided by a positive. The numbers itself don't matter, just carefully think through if it's going to be positive or negative. So our derivative is going to be negative. So our function is going to be decreasing. So decreasing in this interval. Then from negative 2 to 0, let's try plugging in a negative 1 into the derivative. Remember, we're plugging it into the derivative because we're doing the first derivative test to see if this function is increasing or decreasing and to see if we have maximums or minimums. We'll have a negative again on top here. 4 times negative 1. Negative 1 squared is positive 1. 1 minus 4 is a negative number. So the cubed root of a negative number is still negative, times a 3 is still negative. So a negative divided by a negative gives me a positive derivative. So my function is increasing here because the derivative is positive there. Plugging in a 1 into the derivative, positive on top, negative on bottom, we'll have a negative, so my function's decreasing. And then if we plug a number like 3 into the derivative, positive on top, positive on the bottom, positive divided by positive means my derivative's positive. So my function's increasing for that last interval. Remember, it does not always alternate. We might get decreasing, so that would mean negative 2 is not anything special. So we found the open intervals in which the function's increasing or decreasing. First derivative test, negative 2. Since the derivative changes from negative to positive, negative 2 is a min, 0 is a max, since the function changes from positive, the derivative changes from positive to negative, and x equals 2 is a min again. And you could find those y values easily by plugging them in. Alrighty, homework, page 186, 1 through 49, odd.